video. So we're going to kind of continue on with the multitasking stuff. I've got a few things that I did off screen on the main branch. So probably the most important was we did we tidied up some tests basically. So when we go run, we can now go run tests, and everything kind of works as expected. Can't do. I'm not a fan of this test because if you get it wrong, it just panics. But it was one of the first ones. Yeah, so it kind of just works, and you can scroll back. And scroll the whole way back. See all the tests. Sorry about the beats. Quite loud. And you can scroll all the way back. And of note, the vertical tabs, they work when scrolling. The reset term in the form feed does clear the screen, but when you scroll back, it works as expected. Tabs kind of have a tab stop every 8 characters, so there's a tab character there, but it's only a couple of characters, and that has a larger tab. And you can see here where the tab stop goes even more. That is an even bigger jump than that one there. It's just, I don't know, a little sugar, I guess. So that's the stuff I did off stream, and I've got one more thing that's just like in my ready to be put into a commit, and I thought I'd do that now. So if we kind of look at it, we can ignore those two and that one. So in new task, in fact, new task was something that we were explicitly ignoring in asmcheck. The reason why, if we look at that schedule, I think it is new task. So the reason why we did it is this creates a new stack. So mallocs a stack, and then it moves the current stack into EAX and sets the new stack to be this allocated memory, so sets that to be the new stack, and then it does a bunch of pushes. So that doesn't really tidy up that well, because we push a bunch of stuff. The reason why we push a bunch of stuff is because we, in switch to task, which is called to actually switch between the two tasks, we push 4 things and we pop 4 things at the end, and we do similar thing here where we get the stack pointer from the current stack pointer and we save it. Before we do that, we save it to the current task stack pointer, so when we come to swap again, it will kind of just work. And in addition to these 4 values, there's also a 5th value, which we have a comment on, which is the EIP. Because we called that function switch to task, that will push basically the return code. So we want to push that, and then we push 4 things with a comment on that. There was like a to-do, which I'm still not sure whether it needs doing, because we don't actually have this enter stack frame here that other functions do. So most functions have this enter, then a leave at the end. If we do that, we'll have to kind of massage the stack a bit more as well. But anyway, I wanted to get this working, so the asmcheck kind of had a notion of when you're copying a stack and when you're basically when you're switching stacks. So I've wrong key. In asmcheck, we did some sort of a change. Right, so in asmcheck we now have this register state alt stack, and in the state we add this alt stack. So you can see the stuff that I've changed because there's a plus in this slide. Hopefully that makes it easier. So yeah, we basically have a stack, and we assume that if something has a stack, basically when you move into that, in fact we can maybe do no. I think, yeah, I'm in the wrong keyboard layout. Yeah, fix it that way. So if we open up just the other one, so if we open up this, we've got this, so that line, this line, and this line is of note. So what I might do is just kind of have a dummy section here that kind of has them all three in a row, and maybe we'll do that just so we can kind of see what we're looking at. So ESP is our current stack pointer. When we move our current stack pointer into some variable or memory location maybe, we want to basically say that this is defined, but we want to kind of say it's actually defined as like a stack, whereas defined was kind of said to be defined as data. So this is, I don't know, kind of a type thing, but hard to know. So EAX after this instruction will be have the register state of stack. EBX was defined up here, and it will just be defined because it had some memory. In the future we might say that it is data or something like that, but when we move ESP from EBX, we basically check that is defined, and then we clear the current stack, basically saying we're starting with a new stack. Now you might think, well, we've lost our stack now, original stack. So when we set this to be a stack variable, we also have this notion of a alternate stack. So we're limited that we only allow two stacks. So we don't do crazy stuff like modify the stack more than twice in a function. And I feel that's an alright limitation, because how we do the stack manipulation, we don't actually do that. So at this point we take a copy of the stack as well as set that to have the stack variable, and then when we move into ESP a defined variable like EBX, we clear the stack, and when we move it from a variable that has the stack state, we copy it back from the alternate stack, and it's in a way resetting the stack. This has a small issue where not that one. In fact, I don't really need this anymore, so we'll do that and close that one. Runs into the problem that when we return, we need to know that we're back on the original stack. Otherwise, we don't know whether we're like, when we, in fact, I'll just jump to it. So we push some stuff, but then we move it back. Then at this point here, it needs to know that we're popping the right variables that are pushed up the top. And because we clear it at this point here, we move it back at this point here, but there's potential that these pushes here pushed literally the things that we needed to do. So we need to have some notion on whether we're on the right thing. So how we do that is we have this in fact, process func is a better way to do it. So our stack now starts with an initial state on the top, and so when we return, we're going to expect there to be something with initial on the top, potentially with a string, though I don't actually check it. Maybe I should check it. And then we've got this new alt stack. These are just debugging changes that I did. We did some changes here. We weren't actually stopping on iRet, I found. So this wasn't here before, and now it is. So basically it would fall through, which didn't do what you would expect. And we moved that. So the bulk of the change is up here. It's just in that one, isn't it? I suppose, the ret and iRet do this. When we get to the return, we check that the stack isn't empty because we're expecting one thing left on it, and then we check whether that one thing is an initial variable, which potentially this might fail, but because we push it on and then afterwards we check whether it is now empty, it should be the first one, though there is still potential that we create a new stack and then push the initial value on and then push the right things on that it's expecting to pop. I don't think it's unlikely that will happen. And if it's not the initial stack, then we check whether it isn't empty. And if it isn't, then it basically means that we still have more stuff to pop off after this. So it had more than just the initial on, or it potentially had a different stack, but the programmer can work that out. And then we always fail in this case, and basically saying we couldn't find the initial stack. So all the stack magic happens, and the same happens for iRet. All the stack magic happens when we do some sort of a move instruction. It should be limited to just move, but I'm kind of just doing it for everything. Basically, if reg is the dest, so potentially that should be called destination or DST or something. But if we're moving into the stack pointer ESP, then we get the source. We see whether it is a register or not. So if it's not a register, we've got a fixed me at the moment. We can't move from a non-registered. So that could be like a memory address or something like that. And that comes into it in the other function, switch to task, that is moving to ESP from some memory location. So we don't support that yet, but yeah, this is a different nutshell, because this is overriding the stack and then just assuming that the right things are still on. So if it is a stack variable, it means that we can basically set as the alt stack, and we assume that alt stack exists in this point because the code that sets the stack state will set that up, but it is optional, so it could be none theoretically, so this unwrap could break things. And if it is anything else basically defined in this case, then we clear the stack, and if it is undefined, then we can't do it. could be done with this function there, but yeah, in fact that could be a better way to do it, but yeah, hard to know. And then on the other end of things, that's if the source, the destination is the stack pointer, but here we're going to see whether we are moving into a register. So we are moving into a register. We don't actually check the moving into a memory address, which hard to know if we should or not. But here we do the same thing. So we get the source this time, and we check whether it's ESP, and we check whether it's not a stack dereference, because in printf I think we have this, and this reg name will kind of automatically unwrap that, because we want to see whether ESP is defined. So that's just kind of a thing, but it works. And then we see whether we have reset up the alternate stack, and if we have, then we just say, no, we can't do this. Otherwise, we set that destination to be stack, and we set up the alt stack to be just a copy of the current one. And if that doesn't kind of happen, then we just do what we did before, which is set defined. So now when we kind of lint everything, it runs fine. We do see that we ignore the switch to multitask still, but we do process func new task, and it works. So what I might do is skip those two and just kind of go through some stuff we did. So one thing I did was I removed this move from EBX to ESP. The reason why is, if we look at that was basically done here. So it was move EBX from ESP. Now, if we look up here, EBX goes into ESP. EBX doesn't change in those two lines, so we can remove it, and makes the tool happier, because the tool thinks, oh, we're saving another pointer of the stack pointer, and we're only allowed two, the alternate, the real one. So we remove that, and after we did this, we noticed the tool found a bug that I kind of saw quite a while ago. Was we pushed two things there, but we down the bottom used to not push that, and so the tool correctly, in fact we can tool bang tools lint. So if we run this, it should complain EBX altered during function, which is the check for whether things get altered happens before, which it normally means that we're not popping it. And say if we pop like EAX, then it'll complain that it doesn't match with EBX. And say if we try and pop it twice, it should say it's a kind of weird error there. We should potentially check that, but yeah, in fact, I don't know. I'll kind of leave it. But yeah, so that's the kind of change there, and that fixes a potentially bad bug, because new tasks will be getting run quite often whenever we're creating a new task, and we don't want to kind of leave stuff on the stack, because then when we return it doesn't quite work. It's kind of interesting, because the test I did for this was the skip test. It works, so yeah, not sure how it works. Well, I guess like multitasking has been initialized, so once we create the task, and at some point the switch task will happen. Switch to task. Switch to task. So that gets called. Yeah, it gets called in the scheduler. So that gets. Yeah, it's bizarre that this works because, well, it worked because it shouldn't have been able to find the. Oh no, because we did the leave. So all that would have happened was EVX would be kind of undefined at this point. Because we do the enter that sets up stack frame, and then when we leave it gets to the right point, so it will still pop the correct return pointer. But yeah, the skid test wasn't really amazing. All it did was basically say, hey, like this is whatever thread is running. Which, yeah, fun times. And you'll see that new task kind of just set it to 2, and the first one is set to 1. So it's not the best, but yeah, I'll get back to kind of doing that. So there's that pop EVX that we fixed, and then a bunch of stuff in the why might not have done it. All that, and yeah, we can just do that and do that, do that, and do that again. No, did do it. I guess I can fix that another point. Like it's still errors, but the error message isn't good, and that tool, the error messages need a bit of work. So I'll commit that up, and yeah, tools will do that because it's mainly there. And ability to change stack. Just change stacks. This allows new task to be checked, and a bug was fixed. Always good. So we'll do that, and now we'll get back onto the multitasking. So this was kind of a necessary thing, but I just did it in the main branch because it was kind of a bug. What are all these things? Yeah, I'll just dash that. It's kind of my working notes, and I'll merge in all those changes. So yeah, since they're, yeah, that's just like all the stuff for getting test working and stuff, and then a few extra things. So if we do this, and theoretically it should still work as expected. Now for kind of getting stuff. There was a weird gap in there. I don't like that. Yeah, this gap here shouldn't exist. It gets is after that. I don't know why that does it to it here. No, it does. It's annoying when you like find a bug and it still just exists. So what I want to do is, if we look at our kmain, we do this term new, and what I want to do is set up term new to kind of have an entry point of what it's going to do, and then this setup standard and SDIO should get done within term new. And term new should then create a task, I guess, for the function that it's going to call. So term new should set up like the kind of terminal object, set up the file streams around it, and then set up a task to then run that, and that task should then kind of read from the standard in, standard out. So I think let's just open up source scheduler. We want that initialized multitasking. Initialize that one. And so that kind of just sets up the current task to be where we are, and then I think it's skid test. Yeah, potentially don't do that there. And I think I don't actually want to do that there. I want to do it in like boot code. So where do we call kmain? Like down there. So we start interrupts there. So yeah, I think this one will be a good point to do it. Initialize multitasking, and we probably need to. The naming is all over this game, but we'll do that. And this will kind of just do that. I suppose it doesn't matter if we have it, but what I'm hoping is that doesn't break things. No, it doesn't break things. So theoretically, we are running as. I'm also going to do quick change. Turn music. Let me just comment out that sweet beep. So now when we go up, it won't beep. It's trying to beep. Potentially I'll do like a visual builder or like flash the screen and have it configurable. Got some to-dos for that. But yeah, until we do that, we'll do that. So we've got multitasking initialized. So I also had another thought about standard, like the default standard, and we have like a term iOS, and I think the term iOS should only really happen on like term objects, and so it probably shouldn't be there by default on this, and theoretically it can also be on outputs. But yeah, I think what I want to do is basically remove this from here and only have it in the term init. So I guess in the term init here we do term new. Term new, and we're wanting to call it with a start function. So that can be void start function. Start function can be arg1. So we initialize it, and I can kill that, and this. So that's kind of going to be like that, and we want to call new task, and we want to move like ECX. this hack pointer might kind of come into necessity. That will be cdx and start function and ex. To do create in for new task. Oh yeah. So I'm thinking I might do that for now, just before we do the kind of standard on the actual task, because yeah, it gets a bit tricky. Right, so yeah, I think I want to go move EVX. Actually, no, just push EVX and move EVX from EX. And we should probably do like a test EX, and jump zero error. And when we do that, we should probably leave return and error and error. Okay, just call back. And let's go to return. So they'll do the trick, and now we can have all of that. So the init should be setting up that stdio. And so what do? We get it, we create a new stream, we put the current object, and we do the put z. So I think this is where we set up term iOS and copy it from the other one. Yeah, and yeah, when we come to kind of write it, that's when we'll start function. Yeah, we want to. Brain's not clicking in. We kind of want a flow that looks like PS2 goes to a like window manager, which then finds the current active term, which should then go to any term iOS processing, which should then go to the shell, which should, when that writes, it should go back to the term and do some term iOS processing on the output, and then go to VGA. So that's kind of going to be the flow of streams. So this is going to be like a pipe stream, that's going to be a pipe stream. So you can kind of imagine these as all pipes, except like the term to term iOS kind of gets joined together. We also don't have any term iOS functionality set up for outputting, but it can exist. So these two streams, they will be different because the term iOS settings will be different for both of them, and then the shell can kind of manage what it wants for term iOS with the TC get editor and set editor on its standard in, which will be this side, and standard out, which will be this side, and standard error will also be that side. Probably cloned in a way, so you can have a different output depending on that, and then after the processing happens, then it'll do the like term output, I think, or term put C will probably do the trick. And if we didn't have this like intermediate thing, the term would kind of just go straight to VGA. But I think that doesn't really make sense. It's kind of like you're opening a terminal emulator. So this is a terminal emulator on Linux, UXRXBT, and the first thing it does is starts a shell, and no, I won't do that. Yeah, so it kind of starts a shell, and I forget where that functionality happens. I think it's in my like i3 config, config i3 config. Yeah, we start sensible terminal, and that's just running like URXVT, which if you run it from the command line, it just goes blank. Why? Because reasons. And that for some reason calls a interactive bash shell, which I think there's some config that will basically do it. But the idea is that we have a terminal emulator, which is like this window. I mean, inside it also has tmux running, but that's beside the point. My thinking is that we can we do like no, oh, I'm just wondering whether we can run like a different thing. Yeah, so this it's got like the -e, so yeah, we can run like just a sh. So you can run like different things in it, but you need to run something. So that's what we'll do here, and we'll have this shell in the middle. And so we kind of need to set up these. That one, we might not bother with that at the moment, but we can. So when we do this setup standard O, we need to set up a few streams. So the Win Manager doesn't exist at the moment, and how I'll kind of simulate that functionality, like it picking the active term, is probably using this a similar hack term pointer type thing. I'll probably take that away and have like a hack current standard in, and then PS2 will basically find that hack standard in, and then it'll jump that step, so it'll kind of ignore that and go straight to there. Yeah, that's probably about that. So I think I haven't really done much. I'll leave that comment there, and I'll probably see what I've done. Yeah, we do that, and we're setting up the functionality to do that, and it kind of still works, which I think is good. I actually wonder if yeah, we can't do that. Lib term, yeah, brain's not quite in it. Extern panic. This one, I guess. Don't do that. Skid test. Yeah, so that like breaks. That's another change I did. That this shows where we caused the division by zero, which happened in boot 32 apparently, which I wonder whether that's actually the case, because the stacks probably get a bit mixed up. So potentially stepping through that one. I think I'm going to leave it here because my brain's not quite connected up, it feels. But I'll hopefully do some more maybe today, and get a bit more working. There's a few different kind of things to check here, but I'm keen to basically get something working in the kind of multitasking type thing. It might require a bit more work, but I don't know, it's like all the parts need to come together all at once, but I need to kind of break it down into the small steps. But yeah, that's probably it for now. Hope you enjoyed watching this somewhat video. Kind of tells us that, I don't know, take it how you will. But yeah, thank you for watching. If you enjoyed it, let me know, and I'll see you later.